So we're going to be looking at combining random variables here, some more to do with the functions that are given to you, the formula that are given to you. And just to be clear about this, these ones will be given to you, but these ones will not. The difference between these is that here I'm going to add two different random variables. So for instance, rooms and number of dinners sold at a motel every night. So we've got two different random variables, x and y. When we combine them, we add the expected value. When we combine the variance, we also add the variance. This is just an example for you to think about, because sometimes we're not adding the random variables. You might have to potentially subtract a random variable, like a discount or a coupon. Here you'll notice that the expected value, or the mean, is going to be subtracted, just like we would see here. But the variance, even though we're subtracting these random variables, the variance is always positive. So that's one thing I want you to keep in mind. The variance, always positive. It's always adding the variances. So in this situation, we're looking at combining two different variables, but sometimes, just as a sneak for it, a little hint, we often combine multiple versions of the same variable, and in that case, which we'll look at next, would be something like this, where we add the same thing several times. But we'll look at that in the next example. So, in this situation, the motelier from the last problem has a mean nightly room occupancy of 3.55 rooms and a standard deviation of 1.43 rooms. The restaurant has a mean number of dinners of 5.2 with a standard deviation of 0.82. The rate for a room is $80 per night, and the dinner is $20 per person. What is the mean and standard deviation of sales, which is your room and your dinner, per night for the motelier? So we'll let the sales equal the number of rooms occupied plus the dinners sold. And in this case, that's going to be times $80, because it's $80 per room, and times $20, because it's times $20 for a dinner. And we'll call the rooms X and the dinners Y. So my expected value for sales is going to be equal to $80 times the expected value of the rooms plus $20 times the expected value for the dinners. And that's coming from my formula here, where I know that I just have to times the multiplier by each of the expected values that it goes with. So A times the number of rooms and B times the number of dinners. So in this situation, we will get 80 times the mean number of rooms, which is 3.55, plus 20 times the mean number of dinners, which is 5.2. And this adds up to $388 in sales. And to make sense of this, in sales on an average night. And you'll notice here there was also a change of units, like we talked about in the previous video. We've gone from rooms and dinners to dollars. So there we used our given formula. The last thing that we need to piece together here, though, is we've done the mean, but we need to do our standard deviation. So the variance of the sales is going to be equal to, and remember when you look up here, the variance is always squared, and squared in this case because we're changing units. So here it's going to be $80 squared times the variance of the room plus $20 squared times the variance of the dinner. So that's going to be $80 squared times, now the variance, remember that's just the standard deviation squared. So our standard deviation for the rooms is 1.43 squared plus the $20 squared times the variance of the dinners, which is 0.82 squared, because again variance is the standard deviation squared. So when I times all these together, I get a really big number, 1356.32. And remember to get back to standard deviation, because that's, $13,000, it's like, what are they even talking about there? It should kind of make sense to you that you're not done yet, because it's a ridiculously big number. So go back to the standard deviation. And remember that the standard deviation is just the square root of the variance. So 13,356.32 square rooted is going to be equal to $115.57. So the mean sales on an average night is $388, and the variance of that is $115.57. So again, that's telling us that on average he'll get the 388, but some nights he'll have a lot more, and some nights he'll have a lot less, and that variance of 115.57 tells us that there's actually a pretty big swing, because that's not that much smaller than the average. And again, just to clarify here, because we're going to move on to a different type of problem, there was a change of units in this question. We were talking about rooms and the dinner, and we wanted to figure out the total number of sales, so we've done a conversion of the units. So in this case, we used the squared term with the variance, which is the important thing to notice here, a squared and b squared.